Great stuff. So, hello everyone, and welcome. Thank you for joining our session today. My name is Niall Quinn. I'm a client manager here at Coeo. We appreciate you joining us today for this session on optimizing production with machine learning. I'm just going to give you a quick brief about Coeo, and then I'll let Dan Jackson, who's joined us, dive into the session. But here at Coeo, we have over 15 years experience working with organizations transforming businesses through the power of data and analytics. So Coeo was built with the aim of helping clients predict their future, and our core business functions sit in four key buckets. These are data platform, data analytics, artificial intelligence, and data visualization, all of which are developed through our data strategy service and then underpinned by what we call our Coeo managed service. So today's session will focus on our artificial intelligence workstream, and therefore I would like to introduce you formally to our speaker, Dan Jackson. Dan is an analytics consultant with extensive experience in the Microsoft technology base. He'll be guiding us through how machine learning can dramatically improve yield and reduce waste in production processes. So with that, I'll hand over to Dan to begin our session. Over to you.
Thanks, Niall. Yeah, so today I'm going to be diving into a bit of a use case here. I think it's quite good to actually look into specific implementations, specific examples of success, because I think quite often, especially in the world of machine learning, AI, all that kind of thing, there tends to be quite a lot of theoreticals talked about, like this is going to change your business, this is going to make a big difference. So I think it is quite refreshing to be able to then look into examples of where it has been used with success and talk a bit around that story. So that's what I'm going to be aiming to sort of take you guys through today. As we're going on, I think we do have the Q&A at the side, so feel free to put any questions or anything comes up in the chat. I will try and keep an eye on it, and if I do miss anything, we will loop back around at the end anyway for a full Q&A. So we'll catch it then if I don't manage to spot it during the session. But yeah, with that, we'll begin. So I am a senior analytics consultant here at Coeo, and I've been here for about 5 years now. Across that, I've worked on a bunch of different projects across sort of the Microsoft stack. And with this one, obviously, it was focused across machine learning, and sort of further on as we progress, I'll dive in a bit into the sort of specific technologies we used, as well as bits on the architecture and all that side of things. So a bit of an agenda for you guys today, sort of short and sweet. To start with, I'm going to go into sort of the aims of the use case. So what we were trying to achieve, sort of the brief that we got from the client. And I'll follow that up by talking a bit about the outcomes, where the successes lie, what the benefits of it was for that client, and then finish off. We'll do a bit more of a deep dive into the architecture, into how we put the solution together, and sort of where it now stands. So if we start off with sort of the aims of the use case. So this was a client sitting in the manufacturing area. And so their particular interests sort of lay with them producing their products in the most efficient way, So a lot of their products use the same raw materials. And so if they can pick best batch of a specific raw material to use, it means they can use less of it to make the same amount of product, which will increase obviously their margins overall, and B, it just makes it more efficient for them overall. So if we take a bit more of a dive into what they were wanting to do, it was basically around allocation. So if they had a list of products, you can see here the green boxes that they wanted to produce on a given day. They would then also have a list of what batches of raw material were available for those products on that given day, and then obviously details around those batches. And from a high level, they had some like historic predictors as to what they may think how a batch might perform or how it might not perform. So kind of if we take this example as a very high level, if they pick to use batch 1 of the raw material to create product 1, they would end up getting a yield of 78%, which is just saying that if they used 100 kilograms of batch 1, they end up with 78 kilograms of product. And equivalently here, you can see that if they use batch 2 to make product 1, they would have a higher yield. So if they used 100 kilograms of batch 2, they would end up with 85 kilograms of product, which obviously that higher yield percentage obviously means more product produced, or equivalently, it means that you'd need to use a lower amount of batch 2 to make the same amount of product. And so obviously this gets slightly more complicated. The more products you have, the more batches you have, there becomes a lot more different sort of permutations with how things can go and whether there's enough in a batch to make enough of a product, or whether a batch can we go to multiple products, and it's sort of the complexities sort of grow as the problem gets bigger. But in very simple terms, they just wanted to be able to pick best batch that's going to give them the best yield for a product, to then obviously maximize their margins from that side of things. And so that's what we wanted to address. I'll go into a little bit more of a breakdown later on as to sort of the steps to get from the raw data all the way through to this allocation, and sort of the different bits in between. But yeah, that's kind of what they were aiming to do from a very high level sort of perspective. And so knowing what they wanted to do as a project, it's quite good then to talk about some of the successes, which also covers off a bit linking to obviously why they wanted to do it in the first place. So obviously those higher yields, better margins, but it's good to be able to put some numbers towards some of that just to make it a bit more tangible, and also having that means, like, from their perspective, it's easier to sell it across the business. So yeah, when we're talking about successes, obviously the first one is that the system has been rolled out and started to be used in production, which is obviously, always a success, always a good thing, especially with machine learning and data science, because a lot of it can be experimental. You might start off with a data set and have questions, and the first question being, like, can we learn from this data set? Do we have enough data points? Do we have enough information to be able to answer the questions that we're wanting to ask? And so in this case, we did. Another success, obviously a big one for the business, is that by increasing the overall yield across the manufacturing plant by a few percent across the year, it can total savings of over $1 million for them, which is obviously a big positive. And that was always the carrot leading the way throughout the project, was sort of where they wanted to get to. But besides that, with this sort of project, obviously, it's very easy to get lost in that headline number, and obviously that headline number is great, and as an outcome, it's sort of perfect with what you want. But it's also good to reflect on other successes that sort of sit alongside it. So where they were as a business before implementing this was that instead of any sort of automation, all the allocations were done by planners on the shop floor. And so all the knowledge was just stored in those planners' head. So from experience, they might know, this batch from this country or this batch of this properties has a greater chance of creating a higher yield for this product. But a lot of it wasn't necessarily recorded. It was more, what different planners may have learned over time. So with that, there's two things. Obviously, it's very dependent on how good your planners are. It's also very important that you then keep hold of your planners, because if they leave, that knowledge leaves with them. So by going over to this approach, it did allow for a certain level of sort of knowledge capture, sort of actually translating some of those unwritten rules in the planners' heads into sort of concrete written rules to allow the business itself to have more knowledge of the processes and what it was actually doing and why certain decisions were being made. And to have that captured again is sort of invaluable, and to have that sort of knowledge shared. And alongside that, also, it's just a more of a modernisation and a moving to a data-driven strategy, because in this instance, even if the ML segment of it hadn't worked, or hadn't been as successful, the project as a whole would have still been able to function, and the ability to automate some of that allocation would have still been there. And the fact that then that side of things would have been automated would then still aid those planners on the floor. It would allow some of the easier decisions to not have to be made by them, and it would free them up to focus on different things. And so it would still then have less of a reliance sort of on a single point of failure in those instances. It'd make it a lot easier to sort of measure the processes and all of that. So obviously we've got the headline figure, but below that, as a terms of how the business functions, there's also a lot of additional benefits and additional things sort of gained by running the project as a whole. And obviously the final one here is improvements in data quality as well as data capture, and just giving the business a better understanding of what data they have available, how they're capturing it, and also the quality of it, because in a lot of instances, and this is no different, not everything that is useful is always captured, and if it is captured, unless it's being specifically used by someone, the quality isn't always that great. So this did allow, again, the business users to have a better understanding of what processes and what things they were capturing around the manufacturing process, and also improve that so that they've got better visibility overall and they have a bit more trust within their data as a whole. So with that in mind, I'll talk a little bit into the architecture and how it all sort of came together. So I'm going to start with a very high level, obviously breaking it down into 3 sections here, and then following this I'll go into an architecture diagram a bit more, and talk through the actual technologies that we used for it. So when we think about what needed to be done, what needed to be achieved for this project, obviously the very first part, the starting, being able to ingest and transform the data. Obviously we need to, for an allocation run, we need to be able to know what products are being made on a day, what stock we've got available. And on the flip side, because we can sort of think about this in 2 parts. So the first part is that allocation run when we're wanting to be able to work out, oh, what should be allocated to this on a certain day. Then the other side of things is, obviously, because we've got an ML model in here, we need to be able to train that model on the latest data and refresh that again so that it's continually learning and continually improving. So yeah, that first box is more about just preparing the data, joining a few different tables from different places together. It also has a significant amount of business logic in there. So certain raw materials might not be suitable for certain products. So there's a lot around filtering out of those, applying business logic to what is acceptable, what isn't acceptable, all of those kind of things. And then if we move on to this headline box, so prediction of yields, this is where the ML came into place. So the ML for us is basically around, if we have the raw material and we have a product that we want to make, based on the properties of that batch and stock we want to use. We want to be able to make a prediction as to what sort of yield we can expect for that product. And so that's where the ML came in. We had a number of features around the batches, such as like density, origin, age, and a whole number of different things. And for it, we were using a regression model. So regression models themselves are basically, if you've got a set of variables, it wants to be able the regression model is there to describe the relationship between those and the field that you're trying to predict. So using those, it was then able to make a reasonable prediction. And for this project, the client already had some predictions of their own, not using any ML or anything fancy, more just using averages and sort of things that they thought were reasonable. So obviously when we were looking at creating the model, training the model, the main aim for us was that our predictions should be more accurate and closer to reality than the predictions that they had before. And so, it's important with projects like this to have that good understanding up front of how accurate you need the model to be, how you're going to measure it, to measure if it's acceptable or not. I've seen other scenarios, if you're doing classification, say you need to put it in the right category, you might need the accuracy to be higher, like it could be critical, the decisions it's making. Whereas in this scenario, if we were already going to be able to do better than what they had currently, that in itself is an improvement and is a success. So as the process of going through this, again, starting with sort of the data science, we had a data set, a number of different features for the batches. It's a bit of sort of experimentation, which features themselves are most predictive of how it will perform, doing some investigation into those, trying different models, getting a feel for how they perform, which sort is performing the best, and sort of going through that process to the point where we ended up with a model that we and the clients were happy with and was producing good enough predictions. And then the model itself is also retrained weekly. So this was basically because if we look at the amount of products that they're making in a day, there wouldn't be enough new data at that granularity to make sense for retraining the model with the new data. So we picked a week to allow it to have enough new data to be able to actually have some impact. But we also have some sort of safety mechanisms and stuff in check around that. So within Azure machine learning, you can register different models and select which one's used by an endpoint. So when we train a new one, we'll also check. So there's a number of metrics against it, and we'll check those metrics, compare them to how the previous one was performing. If there's something flagging up as outside of like an expected deviation range, we'll flag that up for investigation, so that the model that's being used in production is always trustworthy, and it's not under any drift, and it's not performing in an unexpected way. So there's mechanisms to sort of control all of that. Alongside that, the final point is, once we've got that pairing, to then be able to do the different allocations. And so the allocations take the output of the ML run. So we've got all our predicted yields, and then with that, we have then a number of rules. We convert those to sort of with some sort of linear programming on them. So in essence, we turn those into a number of like mathematical rules. So saying that if this batch is 100 kilograms, we can't use more than 100 kilograms of this batch, and obviously some more complicated examples. We then run this algorithm against it, and it optimizes the overall yield, and sort of produces that as an output, which then goes to the planners to be able to use on the different lines. And so yeah, that solver sort of go through it, and it might be in some scenarios that there's not enough product, or there's not a suitable batch for a product, and again, we'll loop through that, and it'll get fed back, and all of those different bits is all sort of handled within it. So yeah, just if I finish off by sort of covering a bit more of the technologies, and obviously again, because this has all been like high level, I've not wanted to delve too much into what specific ML algorithm we've used or stuff like that. But again, if there is interest in that, again, you could welcome to fire questions now, fire questions at the end. If you have questions later on, or you're watching the recording of this, feel free to get in touch with us as well, and reach out with questions. But yeah, if I talk about the actual technologies that were used within sort of the Microsoft stack, for the whole orchestration of it, we were using Synapse and Synapse pipelines. The data itself stored across different lakes, so different storage accounts, with Databricks doing a lot of the heavy lifting with the business logic, the transformations, and all of that stuff, and the allocations at the end. And then the actual machine learning, we have a couple of pipelines within Machine Learning Studio. So obviously we've got the one pipeline, which is used for allocations when we want to, or the predictions when we want to actually use it, and then there's another pipeline for retraining the model. And then within machine learning, we've also got a batch endpoint deployed, and that batch endpoint is what we hit to do the predictions themselves. Obviously, there's a number of different endpoints you can use within Machine Learning Studio, so you can use sort of real time if you're wanting to just send one thing, predict it straight away, get it back. Obviously, in our instance, where we've got a long list of things to predict, we use a batch endpoint where we just send go and run against all these different things and feed us back the output. And with that, obviously we get the output allocation, which we send back and it feeds back into one of the client systems. But we also have a few Power BI reports and stuff that sit over the top of it. Some of these sort of allow client to sort of have a better idea of how the model is performing, lets them get into a bit more detail in sort of an easy access way, so they can go, oh, for this product we seem to be really accurate with our predictions, or this one we seem to be less so, and it allows to feed back into tweaks of the model itself. It also allows them to see based on the allocations that this system provided us, we should have used these products, or these materials for these products, but actually on the shop floor they seem to have used completely different batches. And then it allows obviously them to have that conversation with the shop floor and go, why did you do something different? It might be that there's just another piece of business logic in the planners' heads that wasn't captured originally, or elsewhere, but it just helps with sort of garnering that confidence and sort of having that understanding of what's happening, because realistically, for maybe a lot of the users, it could just all seem like a black box and some magic is happening over here to give us this result. So it just allows a bit more accessibility to it, just to help with that sort of process overall. So yeah, that kind of is the very sort of quick tour of the project. Obviously, it's covered off a bit of what that project was aiming to do, the successes of it. Obviously, the headline number is that increase in revenue, and then a little bit about the different components of it and how it was all pulled together, finishing off with the different technologies that were used. And so with that, I'll lean into sort of opening the floor up for any questions that we may have.
Brilliant. Thank you, Dan, for that overview. I have a couple of questions, if that's okay. The first one will be what was the process of rolling it out to production like, and how did the wider business react?
Yeah, thanks for that, Niall. So obviously it's interesting from our side, and then also interesting from the client side. So obviously from our side, the project is almost at completion at the point where we've built it out, but from the client side, that is almost the start for them, and how they go about getting that buy-in from the rest of the business. Especially within this client, as they had quite a few slow moving parts, quite a few people not really wanting change, quite a few people happy with the status quo. So obviously with that, they have a number of different lines. So for them, it was a lot about building confidence. So it was very important to be able to see the impact right from the get-go. So they were able to pick a few different manufacturing lines, start using it on those, sort of prove that it works, sort of iron out anything. But also by having those champions within the business that have a good understanding of sort of what's going on, to be able to champion it to the rest of the people and sort of get that buy-in. Obviously, as I said, having some of those reports over the top and having some of those like headline numbers obviously does help. But yeah, it's a lot about having the right people to sort of, you know, roll it out step by step and obviously be able to show the impact that it is having to then sort of get that buy-in across the business as a whole.
Awesome, thank you, Dan. I do have another quick one, if that's okay, and it's I think you mentioned it was quite a specific use case. I'd be interested to know how that would translate to other scenarios and use cases.
Yeah, of course, and obviously that's a good point because this, you know, use case in itself might not be applicable to different businesses. In some ways, it might because you know, still stuff around supply, and I guess a lot of businesses will have allocation problems in different guises themselves anyway. Even if it's allocating staff to projects, allocating resources to something in one way or another, you know, most businesses themselves will have some form of like allocation problem. So in one way, it is quite translatable to similar use cases. But again, as a whole, with like these technologies and sort of the approach that we have here, even for different kinds of use cases, at least the same sort of stack can be used, sort of similar skills. And so while this use case might not necessarily be translatable, there are parts of it that can be used, and sort of their overall, like, at least flow and approach of it is pretty standard and pretty good to apply across different use cases and businesses.
Brilliant, thank you for that, Dan. I think that concludes our session. If there's no questions in the Q&A chat box, as ever, if you do have any questions or you think of anything from the session, happily reach out to ourselves. Our details will follow on with the webinar recording. And if you are watching it on catch up, again, feel free to jot your questions down and pop them back into us. Dan and I'll be on hand over the next week or so just to catch up on any follow-ups from the event. And if there's any other topics that you'd like to discuss, let us know, and keep an eye out for any future events that we are hosting. We'll be at Big Data London if you're in attendance, so keep an eye out for the Coeo stand and the team there. But thank you all for attending, and it's been really great to have you on this optimizing production and machine learning session, and have a great day.